maybe we can start going through the first question. So what did you learn during week one? And there's good points, basic commands in Python, course environment basics, CSC notebooks, a little bit of GitHub. So indeed, last week we covered basic Python data types, variables, giving you a quick overview of these different elements of the course environment. There might be still some more answers coming in here, but I'll switch to the second question, which was the chat. So if you have any problems or thoughts, so sure, these different web pages we have the course page, CSC notebooks, Slack, and also it might still feel a bit messy in a way, but I'm sure that you'll get into the workflow during these first couple of weeks. So don't worry, and if you have any questions, you can always ask on Slack. Come to the exercise sessions to repeat the basic steps and so on. So it will be all right. Then there was, how can I be sure that you well received exercise 1 on GitHub? That's a good question. So we will be posting a very tiny feedback on all of yours GitHub repositories for week 1. So we'll ask you next week to check if you received the feedback. If not, then we'll check that we actually were able to access your submission. GitHub and notebooks are scary. Don't be scared. Long way around to do the same thing. Not sure if I understand what that means, but yeah, maybe Dave, do you want to comment on anything more?
Yeah, no, I wouldn't say there's anything I have in mind necessarily to add to this, other than if you're concerned, for instance, about saving stuff to GitHub. If you get some weird error message or something like that when you're trying to save your files to GitHub, you can always send us a message in Slack. You can send like a direct message to one of the instructors, and we can just check to make sure that we can see your files have been updated on GitHub, just so that you know that you're kind of doing things the right way. The same thing could happen in the exercise sessions. That's a really good place to be able to check and make sure that you have all the kind of pieces working. And just for some reassurance, we do have quite a few elements in terms of how we operate in the course, and all the different pieces come together, and they will all make sense to you in a week or two, how they all link together and why we're using all of these different things. But certainly we understand that at the beginning, just keeping the website straight and all the names of the different platforms we're using can be a little bit confusing, and that's totally normal for students in this course, because I think for many of you, you haven't used any of these tools before, so it's no surprise if it takes a little bit of time to get used to them.
Yeah, maybe still just to wrap up on exercise 1 and last week, so make sure that you have posted your GitHub username on Slack week 1 channel. If you yet haven't done it, you can still do it, but we'll be pulling all the information after class today. So then afterwards we have to add them manually. And what else? And maybe those of you who were working on Sunday, which is of course, maybe we don't encourage you to, but we don't blame you if you do work on Sundays. So there was a little downtime, some maintenance break in CSC notebooks, which shouldn't have happened, but it was down for maybe most of the Sunday. So that's why we then offer these different options such as Binder. So there would be always an environment where you can work on the exercises. So that's also one of the reasons for these multiple options.
And if I might add one other minor thing, just to remind you as well, if you haven't yet filled in the e-form, that's part of the exercise number 1, where you can give us some information about your experience with programming and things like that. Please do that. We'd like to have every person in the course fill that out, because we'll use that for making the pairs for the exercises that we will do in the future. And we'll talk more about what that means during the lesson today in terms of the pairs and the idea behind that. So with that, maybe we could check if there's any other last questions. You could maybe put something in chat if you have any questions still. I think we had a pretty good sense from the responses in the first question of what types of things we saw in the first week. But I'll maybe keep an eye on chat and start sharing my screen. So let's see here if I can get this. So hopefully now you can see the course webpage, and you should now also see that if you go there, you can now see lesson 2 is visible. If you've gone there earlier in the morning and you loaded the page, you might have only seen lesson 1. If you're still in that situation, if you refresh, you should now see lesson 2 is also visible. And so I'm going to go here to the lesson overview just to give you a sense of what we're going to talk about this week. You can see over on the left side the individual pieces of the lesson. But basically, we're going to talk about 2 main things in the lesson this week. And that is some more basic stuff about Python, including using lists in Python that are a very flexible way to organize collections of data. And we'll talk about creating lists and modifying lists and things like that in our Python hands-on lesson for today. And the other main topic for today has to do with version control, which is something that GitHub can be used to manage. And we'll talk about what the idea is of version control, because probably for many of you it's not something you're familiar with. But we'll introduce what version control is, and then we'll talk about Git, which is what lends the name to GitHub, and how to use Git, and then maybe you'll start already to see why it is that we're using github.com to keep track of our course materials. So those will be our main things, and then we'll have an introduction to the exercise number 2 with a little bit of information about why we're suggesting that you work in pairs on these exercises. So that's where we're headed, and I think at this point, unless I see anything in chat, I'm going to go ahead and move on to getting started with our basic elements of Python lesson for today. So what I would encourage you to do, if you haven't done so already, is you can go to the CSC Notebooks page and open up your CSC Notebook instance for Geo-Python. And that should take you to the Jupyter Hub or Jupyter Lab system, where you can then go to Notebooks, to L2 for lesson number 2. And then we're going to be working in this notebook called Python Basic Elements for the lesson for today. So I think we've got something here in chat, just make sure. Yeah, so you can let Walco know if you're having any issues launching the CSC notebook, or if anything else happens like that. I'm going to kind of go a little bit slow here at the very beginning, just so that if you are still launching your notebooks, I don't get way ahead of you. But our lesson today, as I mentioned, is mainly going to be focused on lists in Python, but we're going to start just by revisiting the idea of data types, because that will also be something that becomes important in how we're using and interacting with Python lists. You'll also notice in this lesson that there are some cells that already have things in them. That's mainly to save you from having to type in the information that's in some of these cells. Like, it's just kind of manual, almost data entry. And rather than risking, people getting stuck with typos in putting in this information, we've left information in some of the cells, but you'll see others that are blank. And that's just to let you know that the cells that already have something in them, you can basically just run those cells by pressing Shift-Enter. So we're going to start here with a little bit of data about these Finnish Meteorological Institute observation stations in Finland. These will be getting more familiar to you, I suppose, throughout the course, because we'll be working with this kind of climate data on and off. And here we have a station from Kaivopuisto, and we have some different pieces of information that we have about this station. So we have a station name here, Helsinki Kaivopuisto. I'm just going to run that cell to store that in memory. We've got a station ID, so this is a number to identify the station. It's six-digit number. Then we have the latitude and longitude. I'm just going to run those two cells as well. You can see that they're also numerical values. And then we have the type of station. So this is a Mario graph in this case. And we can also run that cell to store that in memory. So we've basically now stored 5 values associated with this Helsinki Kaivopuisto FMI station in memory. And just as a reminder, we can check what kind of data we've stored using the type function. So we have this function here called type. It's built into the Python default library. So we can check something like the station name by typing type and then in parentheses station name. And if you run that, what you should see here is str, or that it's a character string. And that makes sense. If we look up at station name, we have some text in quotation marks, which is an indication that that should be a character string value. So that checks out. We could also check our station ID. And if we do that, in this case, we get the type coming back as integer, int. And again, that makes sense because this is a whole number, no decimal point here. So that all looks good. And then lastly, we can check our station latitude by typing or running the type function on station lat. And here, the data type that comes back is float, or a floating point number, meaning it's a decimal number. And again, that all checks out. If we check the types of station long or station type, we would similarly see that we get a floating point number here and another character string for station type. So nothing really surprising there. The main thing is that by checking the data types, one of the important reasons we would do that is that certain data types aren't compatible with one another. So you can try and do something like if you add together the station name and station ID. So our station name was a character string. Our station ID is an integer value. And when you try to add those two things together, you get a type error that's essentially saying here that the data types are not compatible. You cannot concatenate a string with an integer. So what Python's trying to do is put the character string station name together with something else. And you can concatenate two character strings without a problem, but you cannot concatenate a character string with an integer value. And so we get an error message here that gives us some indication that there's a problem with the data types because it says there is a type error. Okay, this is all stuff we had seen last week, and I don't think it's particularly, not really much different from what we've already dealt with, so we don't need to necessarily spend much time there. Now, one thing we didn't talk about last week was data type conversions. So if you, for instance, have a station ID that's a numerical value that you would like to combine with your station name, you can do it. It's not to say that that's an impossible thing to do. You just need to first do some kind of conversion to the data types to make them compatible with one another. So an easy thing to do in this case is to create a new variable called station ID str. So this is going to be our way to identify that this is our station ID as a character string. And we could use another built-in function here called str. It's a string function that will convert whatever the value is in parentheses to a character string. So then we could say, let's put in here station ID. So this string function will convert our station ID from a number to a character string, and then we're going to store that with this variable name, station ID str. Now, we don't see any output here, but we could, for instance, check our station ID str variable type, again, using the type function. So station ID str. And we run the type function on this variable we've just defined. And as we expect, it comes back saying it's a character string for the data type. Similarly, if you just wanted to be kind of lazy in a way, you could also just put the name of the variable into one of the cells in the Jupyter notebook And when you run that cell, the last line that's evaluated there will return the value. So in here, where there's only one line, it just returns the value that is associated with station ID str. And you can see here our station ID, but now it's in quotation marks, indicating that it is in fact a character string variable. So I'm going to go off the script here for just a second. Hopefully this doesn't come back to bite us. But for instance, now we could do something like we had our station name, and we can now add to it our station ID str, because this is a character string, station name, this is a character string. And so what Python will do when you use the plus operation with that is just concatenate those two to be a single combined character string. Doesn't look very nice, but now we have our Helsinki Kaivopuisto and then these numbers added at the end. Of course, if you were doing this and we're trying to get some kind of nicer output, you would probably put a print statement and maybe put the station name and then some additional text and then the station ID str. But the point is here that we've now made our two data types compatible by doing this data type conversion. And there are some other possibilities as well. I don't think we cover them in great detail, but you can also do conversions from integers to floating point numbers to integers, and other things like that. And there are built-in functions for doing that. And maybe I'll leave it at that for the moment. So this is mostly kind of reviewing things, but at least here now we've done this kind of data type conversion, which gives us a little bit more of a new skill to be able to apply. And yeah, you can see, for instance, here in the little note, this looks a bit nicer on the course webpage than it does in the Jupyter book, Jupyter notebook. But you can see that there are these other built-in functions, int to convert to integers and float to convert a number to a floating point number. Now, at this point, we have an opportunity to check in with you folks and see how things are going. So the class polling page, you can see the URL here. You can also find it in the chat on Zoom. And there you will find a couple questions about Python lists. I think if I switch over to this view, maybe I'll need to, oh, okay, it looks like Wolko is doing magic in the background. So she has now changed it to show this question 2.2, so you can go there and fill in your prediction for what would happen if you execute the following in a cell in a Jupyter notebook. So in this case, printing station ID plus station lon. And we'll give you a moment to fill in your predictions of what you think would happen, and then we can talk about what we would expect to have in that output. But we've had enough responses here, I think, now that maybe I'll start just saying a few things. You can see it looks like we have two main competitors. We have either a type error or this combination of station ID plus station lon, so 132.334.96 as the output, which would be the combination of adding those two numbers together, and or a type error. Those are the kind of main competitors, and the syntax error is now being abandoned entirely. Okay, so yeah, what is going to happen here? We have a station ID, and our station ID is a numerical value. And this numerical value is something that is completely compatible with a floating point number in this case. So there's not any concern about these two data types not being compatible. Adding an integer to a floating point number is not a problem in Python. They are compatible with one another. And as a result, in this case, the expectation would not be to see a type error, but instead we would get output that looks like this, where the two numbers would be added together. Our station ID is a 6-digit integer number. The station longitude is a two, I think it's, I don't know, 24.96 or something like that. So this would be our station longitude as a numerical value. When you add those two numbers together, in fact, what you would expect to see here is 132,334.96. Again, the reason for that is because these are compatible data types. And if we had some that were incompatible, that would be an issue. But certain data types, floating point numbers and integers, for the most part, you can do math with them without any concern about whether it's an integer or a floating point number. I don't really think in Python 3 that I can think of an obvious case where you would get into trouble with using floating point numbers when an integer is expected or something like that. When we get into the lessons in a few weeks, you can get some warning messages and things in certain situations. You're using a floating point number when an integer is expected, but in general, adding things together, no problem. All right, now we have another question here. I think it's good. It looks like you've been able to also already go and fill in some votes there. So if you haven't yet, please go and add your responses here. Maybe I've inadvertently given away the answer to this already. I did not pay attention to whether or not, well, I didn't remember what we had in the poll question, so sorry about that. I guess there's not really a great deal to say here because we've done this basically. We have our station name plus station ID str. If you jump back over here to where we left off in our Jupyter notebook, we did station name plus station ID str. We got output that looks like this, Helsinki Kaivo Puisto, and then the station ID number, so 132,310. If we added print around this, we basically get the same output that we see here for this option number 43. So my apologies for jumping ahead and inadvertently answering this question before we actually got to it. But I hope you understand here that this is a station name that's a string, a station ID that's a string, and of course adding those two things together as character strings will just concatenate them to form one longer string from that output. And just for the sake of demonstration and to make the point, I think we had the other option was to do like print our station ID plus station long, I think it was. And when we run that, just as I mentioned, these are compatible data types, integer and float, and we get the output here of 132,334.96, the combination of those two numbers. And yes, I think that's maybe that. Do you have any questions about this example or anything? If you do, maybe post something in chat and we can try to clarify anything that might not be clear. Otherwise, we can move on here to our next thing about combining text and numbers. And in this case, you could imagine that we might want to, in some cases, add things together, such as bits of character string, bits of some numbers, and form a nice, well-formatted string of characters. So we could create a new variable here that would have our station name and ID. But we can do it in a way that ends up with a little bit nicer looking output than we had earlier. So we have our station name here, that's a character string. And to that, we're going to add some extra character string here that will be in a pair of quotation marks, just this colon and then a space after it. So this will concatenate this character string for the station name plus this other thing here. plus we can now add the string function with our station ID. So if you didn't want to convert station ID and make a separate variable called station ID str, this is very clear when someone looks at the code to see that all you're doing is converting a number to a character string. So having a separate variable is not necessarily beneficial in this case. And as long as we do this conversion to being a character string, we can add this piece plus another character string plus this station ID converted to a character string. And so we have this new variable here called station name and ID. And if we print out what station name and ID looks like, we now see that we have Helsinki Kaivopuisto :space and then the station ID. So you could modify that further if you wanted to, make some nice looking output. But the point is that we can use this string conversion function in line with adding other string pieces together to form something nicely. Alternatively, we could substitute in here our station ID str. And if we run that, we get the same output because this is the station ID that's already been converted to a character string. So I think in most instances, you probably would not make this separate variable to contain something. It's just simply a conversion of an existing variable to a character string. You could just use the string function like that. That would be my sort of suggestion of how to do things. Okay, so that's the sort of wrap up for the data type stuff and doing a little bit of data type conversions. And now we'll move on to our next topic and the kind of main focus, I think, for today's lesson about Python lists. The idea with a list is that it's a variable that can contain several different values in what's called generally a collection. So a list is one kind of a collection. In Python, there are other data types that also can contain several different values together under the same name. But here we have our list as our first starting point. So we're going to make our first list here called station name. Hopefully you all see that create a list of selected station name values and print to the screen. Oops, it should be station names. But what we want to do here is we create this variable called station names. This is already a cell that's filled in, so you can just run this. This is going to create a Python list, and we'll talk about what that means in just a second, but let's print out what we have here in station names. So I print that, I see basically the same output of what I typed in here. And this is, as we'll see in a second, our Python list, and we can use the type function, for instance, to check that. So let's just take a look here at station names with our type function. And what we see if you do type on station names is it comes back saying it is a list. All right, what does that actually mean? Well, here you can see something new we haven't seen before. These are the kind of square brackets on either side of some group of values. Here we have created our list by putting square brackets on either side of this group of values. So when you assign a variable name, if you put square brackets around it, it's an indication to Python that you're creating a list. For the values that go into the list, you then list them. So here we have several different names of some FMI stations in Helsinki. And each one here you can see is a character string. So quotation marks on either side. And then there's a comma separating the values between them. So square brackets, and then using commas to separate the values inside. Whether or not you have quotation marks here will depend on what kind of data you have, but we have, in this case, character string values, so they're in quotation marks. So that's the way in which we can easily create a list in Python. And you can see the sort of summary here in the notebook about the pieces you need to put together to create the list. One of the things that's new or will be new to us in dealing with this idea of a list is something called an index value. The index value is the way in which we can refer to individual items in our list. And so it's a number that can be used to refer to these individual stations within our list of station names, for example. So if we were to print out the first item in our station names list, we could do a print statement, station names, and then here, to indicate that we want to refer to a specific value in our station names list, we then list a number inside of a pair of square brackets. So you have the variable name here. This is a Python list called station names. Then we have the square brackets, and inside of it, the number 1. Now you might think in doing that what this would do is give you the first value in our station names list. But if you scroll back up, you see that the Helsinki Kaisaniemi is not actually the first value in our list. It's the second value. This is an important thing to be aware of in Python. And that is, when you have lists of things in Python, the indexing starts with the value 0. So the first thing in any list will be at position 0, not at index position number 1. So if we want to see the first value on our list with our print statement, we actually need to do station names and then the square brackets and the 0. And when you run that cell, you now see Helsinki Harmaja as expected, because that is our first station in our station names list. The index value thing is something that's an essential piece of how lists operate. It's a very important thing to grasp when interacting with lists. But admittedly, this is something that can be a little bit challenging for students in the course based on our past experience. So it may take a little bit of time before you totally get the idea of how the index values relate to the values inside the lists. Oh no, we got a broken image link. That's no good. Well, we have a useful little analog here to help us learn a little bit about lists, and I'm just going to briefly jump over to the lesson on the course webpage here, because the link is working for our lovely friend here, Bill. So Bill is our vending machine, and Bill's going to be our analog for how we can understand Python lists and the index values that refer to an item in the list. In case you're curious, Bill's got his name from Dollar Dollar Bill, y'all, like you put money inside Bill. So that's the lame Bill joke for the morning. But the idea here with Bill is that when you want to get something out of a vending machine, you put in your money, and then you can see the items that are inside the vending machine, but you have to choose your item based on some kind of number. So here in Bill, we've got a great selection of items, including lollipops, cookies, hamburgers, tacos, soft serve, ice cream, and beer. And depending on which one of those items you would want, you'd put in the appropriate amount of money, and then you would push a button here, for instance, to select the item. So let's say you were in the mood for a cookie, you'd put in the money for the cookie, you'd push item number 1, and then I don't think we have Bill's little slot where the cookie would drop out, but the cookie would emerge somewhere from within the vending machine Bill. The analog here is that you can imagine that the items inside this vending machine Bill are basically a Python list. It's a list of different items, different foods and drinks in this case. Each one of the buttons that you would push to get something on here is the index value for each one of those items, so that when you want to find a given item, you look up what the index, or you give the index value, and within the list, it goes to that index value and then gives you the item that you would like to have in that case. Another way you can think about that is shown just slightly down below the vending machine bill. And that is to say that if you were in the mood for a taco, you would push button 3 to get the taco from Bill. In Python terminology, let's say we had a Python list called Bill, and if we were to print out the value in our Python list Bill at index number 3, we would expect to see the output word taco. So when you're getting used to interacting with Python lists, when you're getting used to creating them and using index values to refer to items within the list, you can always think back to your lovely friend Bill, the vending machine, because essentially this tells you, in essence, what you need to understand about how index values and the items in the list relate to one another. And of course, if you have questions about the items in the list or whatever, anything about lists or using Bill as an example, of course, you can ask those in the chat as well. There's already one question here about checking the type of information in the list. We will come to that in just a moment. So that's a very good question. And let's maybe return now to the lesson. I'll fix this broken link. Sorry about that. I totally forgot to add the image of Bill when I updated the notebook for this week's lesson. So I'll fix that in case you really want to be able to work in your notebook with a picture of Bill right there to help you remember how things are working. So yeah, we'll come in just a moment to this checking the data types inside of a Python list. And for the moment, maybe I will, I'll demonstrate some of these things in just a second. One of the things that's a useful number you basically commonly want to find for a list is the number of items that are in the list. We have right now station names, and so we can use a function here called len. It's built into Python. And if we do len for station names and run this cell, we see that we have 4 station names in our list called station names. That's the length of the list. If we scroll back up, you can see here when we printed out station names, we had Helsinki Harmaja, Helsinki Kaisaniemi, Helsinki Kaivopuisto, and Helsinki Kumpula. Those are our 4 stations. That seems to make sense. So the len function lets us get how many items are in the list, and just like we expect, we get back 4. Now, one thing you might be tempted to do is, let's say you want to find the last item in your list. This is, again, something that's a pretty common operation. So you might think, oh, okay, I know how to do this. I know I got 4 items in my list. So I'll go here and I'll print out for my station names the value at position 4. Again, this is sort of a, I don't know, cheap example in a way that this is guaranteed to fail because our list contains 4 items, but if our indexing starts at 0, that means we have values at index 0, 1, 2, and 3, but nothing at index 4. So we get an index error here. It says list index out of range. All that's telling us is that station names is a list, but the value you've tried to access is not within the range of index values for items in that list. So it means that if you were to do something like station names len station names, trying to get the last item in your list because you're like, all right, I know the length, I could do the length function to get that. It doesn't work because you actually have to do length of station names minus 1 to get the last item in the list. It's not very convenient. Well, one of the nice things in Python and in dealing with lists is we can actually do a little trick. And that is, you can use negative index values in Python lists. And if you put in -1, what it does is it starts going backwards from the bottom of the list up. So station names -1 is actually going to give us the value at index that's at the last position of the list. So it starts from the bottom now and gives us the last value there. I'll just print out here our station names above this cell, just so you can see here how things are working. So now we're going to go backwards through, and I guess we could have typed that here as intended in the lesson, but we can go backwards through and say, give us station names -4. This works because what it's going to do, it says -1 is the last item in the list, then -2, -3, -4 should give us Helsinki Harmaria. What do we get? We get Helsinki Harmaria. So that's working for us. The trick here basically is that when you want the last item in the list, you can use index -1, and it's a very quick way to get the last item in your list, and it's basically going to work no matter what. No matter how long your list is, it will give you the last item. You can still do things that are not so smart, like print station names -5. If you go above or beyond the start of the list, so like we had here, Helsinki Kumpula as -1, -2, -3, -4. There is no value at -5, so again, you get an index error here, in this case, trying to access an item that's outside the range of values. It doesn't like loop back through from the bottom again or anything like that. So if you go too far into the negative beyond the length of the list, you'll still get this index error. All right. You can see perhaps down here the data types and list topic is coming. But before we get there, it's time for another polling question. So we have a question here that I will pull up on the screen, and perhaps Wolko will switch us over. Look at that. So now we have this list here of cute animals that includes bunny, chick, duckling, kitten, and puppy. We will not spend our time debating which one of those is the cutest, but instead, you can now tell us which animal you would expect to find at index -2. All right, with 39 responses and now up to 42, we have a pretty clear leader in kitten. Of course, things have been designed in a way such that kitten's guaranteed to win, because what kind of internet-based course would it be if the kitten wasn't the cutest animal? And that's right. So when we do the indexing, as you remember, we do negative values. You start counting backwards from the bottom of the list or the end of the list. Puppy would be -1, kitten would be -2, and then if you were interested in duckling, chick, or bunny, you would continue with the negative values that are getting more and more negative, so -3, -4, and -5 to get those other cute animals. I don't think there's much to say about that one. It seems like you're all in agreement, and just remember that this is a very useful trick, especially the index -1 for finding the last item in Python lists or other kinds of collections in Python. Let's do a couple more things here. Now we have another list, and this information's already been filled in for us. So we have here station types that are sort of associated to the stations that we had in our other list of station names. So there are different kinds of stations in the FMI database of their various observation stations. So we can just run this cell. It's going to fill in our station types. And you can see that in this case, the 4 station names we have above are also corresponding with 4 station types. In this case, all of them are weather stations. But it turns out in our case here, we've got a mistake, and the third value in our station types list should actually be Mariographs. So we can change that. And this is one of the features about a Python list. It's what's called mutable. So it means that the values inside the list can be changed. Certain kinds of other data types are not able to be changed, but a Python list can. And so for us to change the values inside the list, we can use the index value. So we could say, for instance, station types. And now at our third position is going to be index number 2. Take a little while to get used to that one, perhaps. And we'll just assign that it should be, in fact, a Mario graph, or Mario graphs for the station type. And then we can print out our station types after that, just so we can see our change. So this is going to take the value that's existing there and replace it with Mario graphs. If we run this, we now see weather stations, Mario graphs, weather stations, just like you would expect. And of course, you could go through and modify other things in the list if you would like, but that's our simple demonstration for this case. Now we'll take another example here to demonstrate data types in a Python list. So now we have a new variable here called station Hel Kaivo that's meant to refer to the Helsinki Kaivopuisto weather station, where we're going to give a station name, station ID, station lat, station lon, and station type. These are all variables we defined at the very beginning of the lesson. And so we're going to put them now all together in a single list about things that are part of the same station and related to one another. As you can see, there's a couple things that are interesting here. We have our Helsinki Kaivopuisto, our station ID, latitude, longitude, and station type now listed here. And one thing I'd like to note is that you can see in our Python list, we have different data types for these different values that are here. We have a character string, we have an integer, we have floating point numbers. And that's a cool thing about a Python list. It can contain different types of data within the same list. It's not like you have a list and it can only contain integers, only contain floating point numbers. Lists can contain all different kinds of data, even other lists if you wanted to. So we can see that. We can also confirm this with our type function. So if we check the type, for instance, first on our list that we've just created, station Hel Kaivo. Excellent typing this morning. We can see that our station Hel Kaivo type is a list. No surprise there. If we want to check the value themselves, we again do our station Hel Kaivo. But then you give the index of the value you want to check. So if we've checked the first thing in our list here, this should be our station name. And I'm just going to add an extra little thing here at the end. This number sign or pound sign or hashtag sign, whatever you want to call this thing, is an indication of a comment in a Python program. So everything to the right of it will be ignored and won't be executed. So when I run this cell, it's basically just reminding me that this first value in here should be the station name, and its type is a character string, just like we would expect. If we maybe cheat a little bit here, copy and paste our earlier example, change it to index number 1. This should be our station ID. And the data type there should be an integer. Sure enough, it's an integer. And if we look then at our station number, at index number 2, this should be our station latitude. And when we run that, we see that the data type is a float. And sure enough, that's what we expect to see. So yeah, the point here is you can check the values and the types of data inside your list by giving the index of the value in the list you want to check. The list itself, of course, will be a type list. And the nice thing is that you can put different kinds of data types inside a single list. Another thing we might want to consider here with our lists is we've shown that you can modify the values inside the list, for instance, converting this weather stations to Mario graphs, as we did for the station types list. But we can also just add and remove values entirely. So if we print out here first our station names list is here, just to kind of remind us what was in that. We can use another kind of operation in Python here where we can delete a value or remove it from the list by using an operation called del. And when you want to delete a value from memory using del, what you should do is give station names. And let's say we wanted to get rid of the first value from our station names list. We could do del station names and then give the index 0. There's no output that gets returned from there, but if we now print out what station names looks like now, we should expect to see only 3 names there. 1, 2, 3. And of course, the Helsinki Harmaio station has been removed from our list. So removing values, you can use this thing called del, and that will basically drop them out of the list. Adding things to the list can also be done, but it's done in a slightly different way. And here, what we would do is, let's say we want to add a station called Helsinki Lighthouse and a station called Helsinki Malmi Airfield. We could do station names dot append. This looks a little different than things we've seen before. This dot append is going to add value to this list called station names. What is the value we should add? Well, the first one we could do is Helsinki Lighthouse. And then we can, after that, do station names dot append our second value, and that's for Helsinki Malmi Airfield. Now in this case, what we should expect to see is that when we print our list out again, we should have 2 additional values, one for the Helsinki Lighthouse, one for the Helsinki Malmi Airfield. If you're doing this, just be careful to make sure that you have 2, like a starting and an ending quotation mark and a starting and ending parenthesis. But if you run that, and now we print out station names once again, you can see now that we have 5. So Kaisaniemi, Kaivopuisto, Kumpula Lighthouse, and Malmi Airfield are all the Helsinki stations we have in our list. Yes, there's a question, yeah.
Do we have to write it separately, or could we have like a comma and then add the Helsinki Malmi Airfield in the first thing? Like,
yeah, good question. I don't think you need to do 2 separate appends, but let's test it out. So if we do station names dot append, let's add fake station 1, fake station 2. Okay, so it does actually look like in this case, hold on, it doesn't want to take it in this form that you just have them comma separated. I suspect it's expecting a single argument, but if you make this as appending this list, I don't know that that's going to do what we want. Yeah, so that didn't really do what we wanted. What that did is it adds in, as the last item in the list, instead of a single character string value or 2 separate character string values, it adds in this as a list within a list for these fake stations that are here. So to answer your question based on what we see here, and as far as I know, maybe Vuokono is different, it does look like for this list append, you have to do them one at a time.
okay, thanks.
Yep. It's not necessarily very efficient, but I'll be totally honest and say that if you're appending things to lists, that's also just not a very efficient operation in general. So there's probably a better way to do it if you're appending many items to a list that wouldn't involve doing this append operation. You should be able to add 2 lists together is what Wolf was saying using the plus. So if we were to try that idea out, let's do station names plus this other list and run that. And so, yeah, Vuoko, as it turns out, is right. I'm not surprised. But doing here, the station names plus another list is a way in which we can combine two lists and join them together to form a single list. So 0, 1, 2, 3, 4, 5, 6. Maybe if I just drop this value from station names for this list that we've added. Index assignment out of range. What? 0, 1, 2, 3, 4. Oh, right. Okay, I just wanted to drop out that extra thing we had in there. So yeah, you can see maybe a little bit more clearly here now that we have our station name list, and then we're appending it with this second list with the two fake station names there. So that is perhaps one additional solution for that problem of adding values to lists. So adding them together as suggested. Okay, and I think our list now is back to its original state with our 5 stations because I dropped out the other one. So yes, thanks. Glad to hear of questions. You can certainly feel free to interrupt us as we're teaching in different things here. So I'm going to show you a couple more things here quickly about just a few other operations you can do with lists. As you can hopefully see, we're very close to the end of our lesson. So we'll see a few other things we can do with lists, and then we'll take a little break before continuing on with version control. One thing I should say here about this append, this is something we haven't encountered previously, where we have the name of some variable, and then this append, is sort of like a function that is built in to be able to operate with this data type. In Python, you would call this a method, and this Python list has certain types of operations, certain methods that can be used to modify things in the list. So you could do something like .append to add a value to a Python list. But not every different data type in Python allows you to append things to it. So let's imagine here, or not really imagine, but let's go through the example of taking our station name list and finding the length of it and storing that. So we could have station name length, a new variable. That's simply len of station names. So this is our variable that will tell us how many stations we have in our list of station names. And if we print out that value, print out station name length, we can see that we have 5 stations as we would expect. If we check the type, just for the sake of completeness, we see now that our data type is an integer, just again, as we would expect. Now, for an integer, we are not going to be able to do something like station name length dot append and then the number 1 or anything. It doesn't really matter. Excuse me. In this case, what you see is that we get an error message that indicates we have an attribute error. It's trying to do something with our data type that doesn't actually have that possibility to do that. So for an integer data type, there is no built-in method called append. And if you think about it, what would you append to a number? It doesn't really make sense to have an append thing. An append makes more sense when you have a collection like a list where you would want to add values to that list. So you'll become perhaps more aware of some of these different data types and what they can do, what are the built-in kind of functions for those data types as we go through the course and as we get more experience with other kinds of data. One thing that's a nice thing that you can do in a Jupyter notebook, for instance, is if you type in a variable name like this, like station names, and then press dot, you can press the tab key and it will pull up the list of possible methods that can be used for the data type station name. So it knows station names is a list, and then it gives you a list of the possible methods you could use on that list. So there's things like count, index, and we'll see a few of those down below. That's just something to note so that when you're looking and you're like, I don't remember if I can do this with a integer or not, you can do the name dot something, and you should see the list of the possible methods you can use for that data type. If we did the same thing, for instance, down here with our station name length, we could do station name length dot, and if I hit tab here, there's a few other things that we didn't see before that would allow us to do some kinds of things to our integer values. I don't actually know what many of these do, to be totally honest, but you can see here some of the possible things you can do to our station name length integer data type. And the same goes for character strings and others. You just press dot and hit tab, and you can see what the possibilities are. So as mentioned, let's check a couple other things that could be useful here. One of the useful methods in a Python list is something called count. It will allow you to figure out how many times something that you type in occurs within a list. So if we did like station names dot count, and then put in Helsinki Kumpula, what this will do is it'll tell us how many times Helsinki Kumpula occurs within our list station names. We run that, we get back 1. If we scroll back up to last time we saw station names, that makes sense. Helsinki Kumpula is only in here 1 time. So that's a nice way to search through a list. You can also do station names dot index and Helsinki Kumpula. In this case, what it will do is it will return the index value of the first instance of this item in the list. So the first time it finds Helsinki Kumpula in the list, it will return back to us the index value where that is located in the station names list. I'm slightly concerned that this is not happening immediately. What we'd expect to see here is it looks through our list called station names, finds Helsinki Kumpula, and then returns to us the value that is the number of the index value where that example text is located. Well, it looks like my kernel is doing something weird. So good opportunity to demonstrate how to fix things when you get into the state that you're stuck with a star in your little box over here for the number of operations you've done in your notebook. One thing you can do is you can go up to kernel and you can do interrupt kernel. The kernel is essentially the Python interpreter that's running in the background. I've interrupted it now, and what I'm going to do is I'm going to restart and run up to the selected cell. So this is going to start a fresh Python 3 kernel and rerun all the cells up to the point where we left off, which is right here. If you're having some kind of weird behavior in your Jupyter notebooks, that's a useful thing to do, especially if you get stuck with the star there. You can do the kernel interrupt and then restart and run cells to the selected one or run all cells. There's several different possibilities there. Let's try this again. Okay, there we go. So now when I run station names.index, it finds that at location 2 in our list, we have Helsinki Kumpula at index 2. So that should be the third item in the list. And again, Kaisaniemi Kaivopuisto Kumpula, yep, it's number 3. That all checks out. All right, last two. reversing a list. So it's possible to use the reverse method to reverse the items that are in our list. So let's print out station names just so we could see it before. So there it is, station names. Underneath that, I'm going to do station names dot reverse. And then I'm going to include 2 parentheses after that with nothing. There's no argument for this. There's nothing in between the parentheses. It's just dot reverse with the parentheses there is going to reverse our list. And when I print this before, like I've printed the station names before doing the reverse, it's still in the original order. If I print station names down here, I now see that Helsinki-Malmi Airfield, Lighthouse, Kumpula, Kaivopuisto, Kaisaniemi. So yes, our list has been reversed as expected. One word of caution here with this method, dot reverse. You do not want to do station names equals station names dot reverse. When you do station names dot reverse, it reverses the items in place and it returns a value of none. If you were to do this assignment here to say station names equals station names dot reverse, that will basically delete your list because it takes the value here in station names, reverses the list, but instead of returning the value of the list reversed, it returns none, which means that when you do the assignment here, you assign station names equal to none and your list goes bye-bye. So that is here in a warning and just something to be aware of that you don't want to make that mistake because it will delete your list. And hopefully you haven't done a whole bunch of processing steps that are not easy to reproduce when a mistake like that happens. So word of warning. Finally, we can do a list.sort method. So here we could take our station names and our station names. In this case, we can do station names.sort. And again, if we print out our station names now, we can see that they've changed order. So now we have Kaisaniemi, Kaivopuisto, Kumpula, Malmi Airfield, and then Lighthouse coming after that. The original order had Lighthouse before Malmi Airfield. So we've now sorted, and we've sorted alphabetically such that this is the order in which things are listed. Now you might look at this and say, why does M come before L? That has to do with the way in which the sorting happens. It uses the ASCII character code, in which case a capital letter is listed first before the lowercase equivalent of it. So capital M actually comes before L in the order of those items. If we had Helsinki-Malmi Airfield with a lowercase m, it would of course be listed after Helsinki Lighthouse in this sorting that's done here. So that's just something to be aware of, as well as the fact that this also returns none. And since it's the end of our lesson and we might as well go out with a bang, I'll just demonstrate how this works. If I said station names equals station names dot sort, I'm going to blow away my station names list. And when I go to print it then, it says none because my list has been set equal to none. So that's why you don't want to do that. My station names list is now gone. And unless I rerun all my cells, I've kind of got to start over with my list. So it's been effectively deleted. All right, I think that is definitely enough from me for right now. Do you have any questions about these Python lists, sorting, some of the other operations you can do with lists or things like that? I'll give you a moment maybe to type anything in chat, or if you feel like you want to just speak up, you can also do that. But this is a good chance for some last questions. I know that was a bit of a heavy lesson in a way. We went through a lot of different things with lists, so it may take a little while for all of it to sink in. But yes, I think if there's not any questions, it is definitely time for a break. So let's come back in 10 minutes. We'll continue just 10:41 according to my clock here. And we will continue with Vuoko introducing us to version control. So let's have a break and see you in 10 minutes.